Hello, Philosophy 102. All right, so this chapter is a little different than the chapters we've gone over in the past. Although I suppose I say that about almost every chapter. The collection of fallacies we're looking at today are different to the collections of fallacies in the first two chapters we looked at. You'll remember the first chapter of fallacies. They were all fallacies of relevance. In the second chapter of fallacies we looked at, they were all inductive fallacies. This final chapter of fallacies combines two different types. So we have formal fallacies and fallacies of language. So again, these are still fallacious arguments. They are all arguments where the premise does not support the conclusion for one reason or another. But they don't have that unifying theme that the earlier chapters we looked at did. So formal fallacies are a special kind of fallacy. Up until now, some of these fallacies we looked at, so argument from authority, for example, you don't want to say that someone's committing that fallacy every time they cite an authoritative source, right? That would be crazy. If a scientist tells you that they did some research and have come to a conclusion, they have not committed the fallacy of argument from authority. Likewise, if a physician diagnoses you with an illness, accepting their conclusion because of their authority is not fallacious at all. Those fallacies are a little harder to spot, right? You have to spot that relationship between premise and conclusion. With formal fallacies, when we see these, they are always erroneous, 100% of the time. They're formal not because they're like wearing a little tuxedo or because they use fancy language, but because there is a flaw on the structural mathematical level in the reasoning they exhibit. So we're going to be taking much longer with these formal fallacies than we have with the other fallacies. The good news is there's only 3 of them that we're looking at. There are loads and loads more, like in the wild, but there are only 3 that we're going to be looking at. And the fallacies of language kind of have that going on, but those go back to that kind of line drawing problem where it's difficult to say whether or not they've happened. So these formal fallacies are my favorite. They are very easy to identify. And they'll lead us quite nicely into proper deductive reasoning. So with that said, let's get started. So in the chapter introduction in our textbook, we can see that in this chapter, we're turning our attentions to fallacies that result either from a failure of form, which refers to the way the argument is set up, or, I have to sneeze, excuse me. That probably sounded pretty weird. I'm sorry. Okay, so these result from a failure in the way the argument is set up. And then in the next section, it's going to be certain misuses of language. So I would like in our notes for us to include a definition for what formal fallacies are. So they're fallacies that result from either a failure of form. Maybe we should include this, the way the argument is set up in our definition. So let's just copy that, and you can see I've already typed out formal fallacies right here. They're fallacies that result from either a failure of form, and we can take out either, because we're just defining formal fallacies, not language fallacies. Okay, there we go. I'm wondering exactly how much I should go into the definition of this. Let's do it. No, I changed my mind. We're going to wait so that we can get some examples on the page, but we can talk about what do we mean by set up. We've looked at deductive arguments a fair bit, and I keep telling you guys that we're going to be coming back to these arguments, that it's not okay to forget them now that we've taken the midterm and now that we're done defining them. This class builds on itself, and it builds on this common vocabulary that we've worked so hard to establish. So I keep reminding you that deductive arguments are structural and guaranteed. I equate them to a mathematical equation almost. They are reliable on that level. But obviously, if you set up a math problem that is nonsense, 2 plus minus, 2 equals 3 minus plus times divided by 4 equals, right? We can say, what am I typing here? It's nonsense. It's nothing. It doesn't mean anything. It's set up incorrectly. What does, well, I suppose that could be a negative sign, but now if we do that, what is this? This is nothing. We have to set up our arguments properly before we can make sense of them. So we're going to keep that in mind when we look at these formal fallacies, these deductive fallacies. And I'm going to endeavor to explain to you guys why formal fallacies are incorrect on the same order of magnitude as this being incorrect. This math equation here, or whatever you want to call it, is never going to produce a sensible conclusion. We don't even know what to do with it because it's set up incorrectly. Okay, so let's return to the textbook. The first of the fallacies, well, formal fallacies that we're looking at is affirming the consequent. What a name that is. So let's get this in our notes and talk about what affirming the consequent is. Man, this font is massive today. Okay, so this, again, is going to be a little different than the other fallacies we've looked at. We're not going to be straightforwardly defining them with words necessarily. So let's look at an example, and we can put this example in our notes as we have in the past. If Jane is a member of a sorority, then Jane is female. Our second premise, Jane is female. Conclusion, therefore Jane is a member of a sorority. So we can see, let's actually take a moment to look at this. That doesn't work, right? That doesn't make sense. The structure or form of this argument is what makes it invalid rather than its content, right? We don't know Jane. We don't know if Jane's in a sorority. We don't know Jane's gender, right? These things could be whatever. The content is not what's in question here. The reasoning itself is what is in question here. Can we really, even if these two things are true, reliably come to this conclusion? I think not. Let's say these are rules written on the universe. We still can't get to this conclusion. So we're going to look instead at the form of it. Well, let's put this in our notes. I think this might be helpful, if I could highlight it correctly. Okay, well, apparently we're just going to have to clean it up in our notes. All right. Oh, Lord. Okay. Maybe I should just get rid of these numbers too. I'm going to pause and clean this up. You guys can do the same. So this looks much, much more tidy. Okay. First, let's break this down into its parts. You've also heard me say about deductive reasoning, which this clearly is, that we can't get anything new out of the conclusion. So let's talk about what that really means here. So we have this part is a member of a sorority. I'm going to highlight that in lavender. And then Jane is female. I am going to highlight in Oh no, that's too dark. We won't be able to see anything in this terrible teal color. Okay, so looking like the 1980s in here, you guys. Okay, we've sorted this out. We also have this down here, right, which is identical to our already blue bit. And Jane is female. And oh, look at this. We have something that we've seen before is a member of a sorority right here. Okay, why I'm doing this will make sense momentarily. So if Jane is a member of a sorority, then Jane is female. Jane is female. Therefore, Jane is a member of a sorority. We've got this pattern, and that's what I want to draw your attention to, right? We go from purple to blue, blue to purple. This is never going to work. It doesn't matter what we put in here, right? To make this a little more clear, let's just put some representative letters in here. So let S be is a member of a sorority and F be female. We can see that the second premise is just F again. And we can see that the conclusion is just S again. All right. You know what? Maybe we should even get rid of Jane. Let's get Jane out of here. Ah, now we've got a lovely deductive argument. I'm liking the look of this. If S, then F. F, therefore S. Hopefully some of you are starting to see what is wrong with this. Now that we've stripped it of its content, because again, these aren't fallacious because of their content, they're fallacious because of their structure, and we've boiled it down to just the structure, we can see that there's some funny business going on here. We can know that it's true that if S, then F, and we can know that F happened, but that doesn't tell us that S is the case. It only tells us that F happened, right? Let's try it out with maybe some different examples. So if I like soup, then I like fries. I like fries, therefore I like soup? I don't think so, right? We can't come to this conclusion based on this information. We can only come to the conclusion that I like fries. So this is called affirming the consequent. Why is this called affirming the consequent? Well, because in arguments of the structure with a conditional statement, an if-then statement, in the premise, we call the first part, I should not type this in front of you. I'll be right back. So, got that typed out nicely for you. The first part is called the antecedent, and the second part is called the consequent. Some of you may be familiar with this from, English classes or other academic endeavors, but for those of you who don't know, that's okay. So I'm going to highlight these in their colors just to kind of help us out, right? Why make it more difficult than it needs to be? So the first part is the antecedent, and the second part is the consequent. If you have trouble remembering this, there are lots of tricks. A comes before C in the alphabet, for example. The consequent is just the consequences, right, of the first thing being true. That one really helped me out early days, right? The consequences are the consequent. So don't be intimidated by this fancy language. It really doesn't. You can call them whatever you want. You can call them A and C. But what do we have right here? Well, this fallacy is called affirming the consequent. So now that we know the names of the parts of a conditional claim, let's look at our second premise. What does our second premise do? It affirms the consequent. These fallacies are named for this. This is where the mistake happens. We think that affirming the consequent proves the antecedent, but it doesn't. And while this looks perfectly obvious once we've got it in this form, it can be really insidious and can trick us. So let's return to the textbook again. So in our textbook, we have what I have essentially just written for us in our notes with slightly different variables, right? We have P's and Q's rather than, what did we use? S's and F's. It doesn't matter because just think of them like variables in algebra. As long as they're fixed throughout the equation, we could put anything we wanted in there. We could put X's and Y's in there if we wanted to. Philosophers tend to use P and Q. So the textbook will use P and Q as we move through these formal fallacies. Down here we have an explanation of, again, essentially what was put in our notes, but if you want to take some time with this, you might. Having, different phrasing for explanations can be really helpful. But what I really wanted to focus on is this argument right here. If this dog is pregnant, then it is a female. That's grammatically incorrect, just so you guys know. I should say then it is a female dog. This dog is female. Therefore, this dog is pregnant. What? We can obviously see that one's wrong, right? Any ladies out there will recognize the mere fact that you're a lady does not mean that you are pregnant. And hopefully fellows recognize that too, right? So we can put this in our notes if we want to, but mostly I just want to go through this same process to really solidify our understanding here. So we've got this dog is pregnant. Let's highlight that in purple because that's what color we're highlighting our antecedents. And it is female in blue. Right? All right, let's continue with our highlighting. This dog is female, it gets highlighted in blue, and I realize this is grammatically slightly different, but don't stress it. That's okay. It has the same content, so it gets turned blue, and then we have therefore this dog is pregnant, which we know turns purple because they're identical. We're just color coding. Nothing intense here. Oh, this is looking mighty similar to what we have up here, right? So let's take this a step further. Let the letter P represent pregnant, and again, let's just say F represents female. And again, this is a process. I don't know how you want to put this in your notes because I realize I'm changing things, and this is our note sheet, but it's also our worksheet. So maybe you just want to separate them out with lines. Either way, I kind of undermined my big reveal there, didn't I? Let's number these. And let's get the word therefore out of there and instead just write conclusion. Oh, wow. This is, very obviously exactly identical to this first one. I guess identical means exactly. That's kind of unnecessary. Yeah, we can see exact same thing. Affirming the consequent. This argument is the same as the first argument we looked at. That first argument seemed like, oh, maybe that's true. Maybe Jane is a member of a sorority. If that one tricked you, recognize that these are the same arguments. They have the same structural flaw. Because again, this is a formal fallacy. The problem isn't the content, it's the structure. You cannot conclude the antecedent from an affirmation of the consequent. This is all new to you guys. I don't want you to be intimidated if this seems like it's moving really quickly or it seems confusing to you. This process right here is something you just go through over and over again until it becomes intuitive to you. And again, this fallacy is really easy to identify once we've gotten used to going through this process because it's named for what the second premise does. They won't always be in this order, but it's named for this move right here, which affirms the consequent. So, if you in your notes you want to color code them differently, or maybe draw like circles around some and boxes around the other, that's fine. The reason we go through this process is to see the essence of the argument, the structure of the argument, the form of the argument. Sorry, I'm going to start gushing. I love this stuff. Okay, let's return to the textbook. So here we come upon what I would suggest you use if you need a written out definition of this fallacy. This form is so called because one premise affirms the consequent of the other premise. So let's get that in our notes, which have gotten very colorful today, haven't they? Okay. So very simple, very straightforward. I think the examples work better than does this definition. But if you just need something to lock in your mind for identifying this premise, just look for, or identifying this argument and this fallacy, just look for the premise that affirms the consequent of the other premise. Very groovy. Let's move on. In the textbook, there are two other examples of this fallacy. I'd like to just take a look at them really quickly. If this theory is correct, then the specimen is acidic. The specimen is acidic, therefore the theory is correct. You guys should be seeing it now, right? This is the same structure as that silly one about pregnant dogs, or all things that are female being pregnant, right? That's crazy. Okay. And again, if any of you guys try to use this reasoning, you will be sorely disappointed. If Sandy passed the final, then she passed the course. She did pass the course, therefore she passed the final. You should be able to see what's going on there, right? Especially in our class, because you don't need to pass the final to pass the course. You need to pass the final to do well in the course, but you do not need to pass the final to pass the course. What might have happened? She might have bombed the final, but otherwise done well enough in the course to pass it without passing the final. So, again, this reasoning might look valid, but it's invalid. And again, because these are deductive arguments, we can help ourselves to this vocabulary of validity, which is a theme that will follow us for the remainder of the class. So these arguments are, just to be very clear, invalid. That is definitely the takeaway here. And they're invalid because of their structure. In fact, validity and invalidity only talk about the structure of the argument. Hopefully you guys can also see why this sort of thing only works for deductive arguments now that we're actually looking at deductive arguments. If you tried to break down an inductive argument this way and make it look like this, I'm not sure what it would be at all. And that's because it doesn't just rearrange the parts. It has new parts that you can introduce or remove or go out and do science on and that sort of thing. And the conclusion is just probably true. It's predictive. It's not just a rearrangement of your premises. Okay, now for real, we're going to move on to the next fallacy. So the next fallacy we're looking at is denying the antecedent. And this is going to be so much easier now that we have talked about affirming the consequent. Because like affirming the consequent, this is a formal fallacy, which means it's a structural problem, and it is named for what one of its premises does. So let's get a look at our textbook. Just as we get an invalid argument when one premise affirms the consequent of the other, the same thing happens when one premise denies the antecedent of the other. So let's look at this example again. If Sandy passed the final, then she passed the course. Sandy did not pass the final. Therefore, Sandy did not pass the course. So I'm going to take this and put it in our notes. That was not what I wanted to do. You'd think I'd adjust the sensitivity of my scrolling at some point, but not all philosophy professors are super intelligent about commonsensical things. Okay. I hope some of you recognized what I did just there. Okay. Let's look at this. We're going to color code it. And again, this is a different fallacy, so it's going to look a little different. And I'm going to introduce you guys to a new symbol. Well, maybe. We'll see. So let's keep our antecedent and our consequent the same colors. So purple and, is that the same purple? Yeah, it is. And blue. But we've got something different in here, right? This is not the same as that purple. In fact, it's the exact opposite of our antecedent, right? The antecedent is the first part of the sentence. Sorry if this gets repetitive for some of you. I promise it's worth it. So what do we do with this opposite of purple? Well, let's get rid of it just for a second so I can do some highlighting. We're going to go ahead and highlight this purple, and then we're just going to put not out front. Or if you want to be really fancy and do some symbolic logic, we can put this out front of it. This is a negation sign. Different logics use different negation signs. And this is the one I was trying to decide whether I wanted to teach you just yet or not. But for now, I'll just write the word not in all caps and make you guys aware that if you see this, we'll be building it into our logical vocabulary shortly. But if you see this, it just means not whatever follows, right? So it is not the case that Sandy did pass the final. Not grammatically pretty, but, you know, this is a logic course, so you'll learn to love it. Again, with our conclusion, it's not the same as our consequent up here. It's significantly different. It's the opposite. So we're just going to do the same thing and highlight this and color code it to match, and then out front we're going to write not, and then I'll put our little notation. So don't forget about this part just because it's not highlighted, right? Just like the if-then is really important, the negation is also super important. So we can already see that this is structurally different than affirming the consequent, right? That's because it's a different fallacy. It's denying the antecedent. So let's go about our business of dropping the content. We'll make this F, and we'll make this C. Well, maybe we'll make it C. And we'll make this F. This process is just to help see the structure. And we'll make this C. Very groovy. All right, now we have a very different pattern, right? We have purple, blue, not purple, therefore not blue, right? Not the same as what's going on up here. So what's happened here? Let's talk about it. So here, the second premise is denying the antecedent of the first premise. The antecedent is the part after if, right? And the form of the argument is, if you prefer using P's and Q's, if P then Q, not P, therefore not Q. The circumstances that showed the previous example do the same for this one. It may be the case that Sandy could either have passed the final or done extra work in order to pass the course, right? She did the extra work, and she did the extra work and passed. In that case, the premises are true, and the conclusion is false. We'll talk more about this last sentence when we move into how to do deductive reasoning properly. right? This is also named for what this premise does right here, right? So once we know what the antecedent is, we can see that this premise denies it and comes to an erroneous conclusion. So just to give you an idea off the top of my head, or to give you a verbal form of this argument, now that we've taken it into its logical form, if I like fries, then I like cream cheese. I do not like fries, therefore I do not like cream cheese? What? No, I just said if I like fries, then I like cream cheese. I didn't say what would happen if I didn't like fries, right? Maybe I just only eat fries if I have some cream cheese on top of them. That might sound gross to you guys. I'm just trying to find things that start with the same letters as our logical form argument, right? So maybe I just like cream cheese that much that I only find fries tolerable if they have cream cheese on them, right? We can't say, well, I don't like fries, therefore I don't like cream cheese. Hopefully this is revealing itself to you. If not, don't stress it too much. We are going to be focusing on this quite a bit. Let's see if we can make up a parallel definition for our denying the antecedent. Because one premise oh, it gives me a suggestion. I like that. Okay, there we go. Learning to do this, again, to reduce the argument to its form, will really help you identify this, because you'll pretty quickly see what's gone wrong as soon as it's in this form. Okay, let's pause this and move on to our next fallacy. So, the next fallacy we're looking at is the undistributed middle, or fallacy of the undistributed middle. Let's put this in our notes. And this one has a very tidy but complex definition. So we're going to take a moment with that. The fallacy of the undistributed middle happens when a speaker or writer, or you, assumes that two things related to a third thing, the middle, are otherwise related to each other. What on earth? This one has a lot of forms. We're not going to go over all of them today, but we are going to go over how to identify it. So let's start where it starts. Okay. All cats are mammals. All dogs are mammals. Therefore, all cats are dogs. Right? The fact that cats and dogs are both mammals does not mean that they are otherwise related. So we're going to keep talking about this as we go through, but let's get this in our notes and talk about the definition a little bit. Okay, we're also going to color code these, but we have three things now. Incidentally, this is called a categorical syllogism, and our next chapter is just all about categorical syllogisms. And one will help the other. So that being said, we have three things, so we're going to have to introduce a new color. Okay, so we have cats. Let's make cats. Actually, maybe we should just start clean with different colors entirely, because this is a different form of argument. All cats are mammals. Let's pick a color for this. Bright green. Oh, that's garish. We see mammals again right here. And then we have dogs, which are obviously not the same as cats, so we'll need to find a different color for them. I want something that's really clearly different. I don't know that any of these are really clearly different. We'll just make it blue. Or cyan. Okay, So let's continue our process. Some of you will just be very upset at me for color coding everything, but I promise there are people for whom this is very helpful. Okay, so assumes that two things related to a third thing. What does that mean? Let's talk about that. So our two things here are cats and dogs, and the third thing is mammals, right? So these two things, cats are related to mammals, dogs are related to mammals, right? That makes this the middle term, are otherwise related to each other. And we can see right here in the conclusion, this assumes that these two things that are related to a third thing are also related to each other. I love that they gave us an example with a incorrect, with a false conclusion, right? Because it makes it so much easier to see. In fact, we can even do what we did before. Get in the habit of doing this, guys. It will save you. Even if it looks silly with this cats and dogs example. All right. Again, these are formal fallacies. The reasons I keep taking the content out of these arguments is because it's not about the content. The reasoning is always going to fail. Just because all C are M and all D are also M does not mean that all C are D. Some of you might have the intuition that you could Venn diagram this, right, with cats and dogs and mammals, each having their own circle. You are indeed correct. There is a way to do that. It may help you to visualize this argument as a claim about Venn diagrams or about sets of things. Ooh, that makes me want to go on a rant about sets, but I'm not going to. If you've done your college math course yet, and you had a professor who was awesome enough to cover set theory, you will be way ahead of the game because you already know how to Venn diagram things like this. Okay, but clearly we can see that that's fallacious and incorrect. Let's return to the textbook. So here is a maybe more believable version of the undistributed middle. All German Shepherds are dogs. Some dogs bite, therefore some German Shepherds bite. Right? So let's talk about our middle term here. Maybe I should put this in the notes. Okay, so we've got this in our notes. Oh wait, no, I got the wrong one in our notes. Let me go back. So the first thing I like to do is identify the middle term. And some of you might be recognizing that these are different arguments indeed, but because this is the fallacy of the undistributed middle, I think our best thing is to identify the middle term. This first example will serve as a great example of what the middle term is. It occurs in both premises, but not the conclusion. That's how we know it's the third thing. Right? That seems so silly, but this will matter. Okay, so we can see that that middle term is dogs. Let's go about highlighting that. All right, what are our other terms? Well, we have German Shepherds. Might as well make them orange. And then because this is not a perfect categorical syllogism, our third thing is things that bite. Biting things. Maybe biting dogs. So we're going to do that blue. And we can see that this middle term does not appear well, it's undistributed. It's unrelated. Um, it's the connecting piece between the two things, right? In this case, dogs and things that bite. But it doesn't actually serve to connect those two things, right? They're unrelated. We're going to talk about distribution when we talk about categorical syllogisms. So again, don't stress it too hard if this seems confusing, but you should be able to look at this and see that it can be true that all German Shepherds are dogs, and it can be true that some dogs bite. In fact, it is true in the real world that all German Shepherds are dogs. And it is true in the real veridical world that some dogs bite. But we cannot from, excuse me, we cannot from the truth of these premises come to this conclusion. We certainly can't guarantee it, right? And with deductive reasoning, the truth of the conclusion is guaranteed by the truth of the premises. So we're going to return to the textbook, but we're going to go back quite a bit. So you guys remember cognitive biases. We're way back here on page 15 of the textbook, a bit of a time warp there. You might remember this argument that we were presented with. All pit bulls are dogs, some dogs bite, therefore some pit bulls bite. That should look pretty familiar. All German Shepherds are dogs, some dogs bite, therefore some German Shepherds bite. It's exactly the same. We recognized when we went over this that this was a problematic argument. I told you guys it was fallacious for reasons we'd get to later, and I am good to my word. We have now returned to it. This reasoning, not only, might we believe it because of our belief bias, but it's also fallacious, right? It has a structural, fundamental problem. We talked a bit when we talked about this, about what this claim means. You might as well conclude that pit bulls are fox terriers. And I said that sounded a bit crazy, and we broke it down. That's because, no, you cannot assume this relatedness, right, between the two things that are only related to this other third thing, this middle thing. I hope you guys are as excited about that as I am, because it's been here all along. You knew something was wrong with this. We just didn't have the vocabulary or the basis to fully explain what was wrong with it, but now we do, and we can see that it is a structural problem. It's this assumption that two things related to the third thing are otherwise related to each other, right? So just being a dog, right, that's not adequate to get to this conclusion, nor is it adequate to get to this conclusion. I think that's cool. Okay, let's dip back to where we were in the textbook. So we've fast forwarded a little over 200 pages, right back to where we were on our chapter on formal fallacies, and we can see exactly what they meant about the fox terriers, right? This argument has the same form. All German Shepherds are animals, that's true. Some animals are cats, that's true. Therefore, some German Shepherds are cats? What? But when we compare side by side these two arguments, let's highlight them. We can see that they have the exact same structure. The reasoning is structurally flawed. This relationship of the two things to the third thing is not adequate to get us to a relationship between the two things. Your belief bias might tell you that this one is better reasoned than this one, but it's not. It's the exact same reasoning at work. They are equally silly. And if you recognize that you would be more likely to fall for the first one than the second one, that's just a really great example of belief bias, right? The conclusion of this one, it is true, right? But we can't evaluate the strength of the reasoning or the structure of the argument on the believability of the conclusion, because there's a fundamental problem in the reasoning of both of these. In fact, it is the same fundamental problem. It is the problem of the undistributed middle. Very briefly, here are some other schema for the fallacy of the undistributed middle. It's just a bit further down in our textbook if you want to take some time. What page is this on? 233. So yeah, just the next page. So this one takes a lot of forms, but we can see it happening over and over again, right? X has features A, B, and C, etc., right? You could have the whole alphabet in there if you wanted to. And Y has these same features, right? This is our middle term. And then we conclude, therefore, X is Y. That is also the fallacy of the undistributed middle. So a lot of these are going to have this syllogistic form with the alls and the sums. Again, don't stress it too much. We're going to be talking about that in the next chapter. But we can see all x's are y's. Some individual is a y. Therefore, A is an x, right? We can't, that individual in question is an x. We can't reliably come to that conclusion because the middle term is undistributed. Okay, another schema, there's a ton of them. It doesn't always take this syllogistic form. Sometimes it looks like these other kinds of arguments, these other deductive arguments that we're going to be talking about with if-then statements. If P is true, then Q is true. If R is true, then Q is true. Therefore, if P is true, R is true. Right? We can see that these terms don't have the commonality that the reasoner here wants them to have. Right? These rules can all be true without reliably leading us to this conclusion. You might want to, just for your own edification, try to write out some sentences that reason this way, or any of these ways, and learn to recognize the structure. This one's a tricky one, but I think it'll come to you, especially once we move on a bit further. There is one final version. Oh, this is an example of the last version, I'm sorry. That's why I was suggesting you write it out. Okay, so what does this mean? Let's look at it. If Bill wins the lottery, then he'll be happy. If Bill buys a new car, then he'll be happy. Therefore, if Bill wins the lottery, he'll buy a new car. Can you guys see that this is the same reasoning that's going on there? I find that a lot of conspiracy theories kind of rely on this sort of reasoning, right? But frankly, the connection's just not there, unfortunately. So that is the last of our formal fallacies. As I said before, we're only going to be doing 3, and you can see we have our first one, affirming the consequent. We have our second one, denying the antecedent. And we have our third one, the fallacy of the undistributed middle. So if you'd like, I know I would like to, let's just draw a little separating line before we start on our language fallacies. The first of our language fallacies is called equivocation. And I'm just going to take this big red all caps one for our notes. So equivocation is also just a word you might have heard used in the English language. In this one instance, well, probably other instances in this class, that definition is absolutely fine. Equivocating is always wrong. So let's get a look at this. This is a way ambiguous claims can produce a fallacy. So let's look at this one. All banks are alongside rivers. The place where I keep my money is a bank. Therefore, the place where I keep my money is alongside a river. So what's happened here is an equivocation between the two different definitions of bank has taken place, right? These are simply two different things. We've made an equivocation between the two. It's a fantastic word. I hear it in politics all the time. Guys, learn this word. It's great. And also, don't make equivocations. They are awful. I think this one's pretty obvious, though, right? Clearly, the word bank is used in two different senses in the premises of the argument, and this makes the argument invalid. Let's look at this more sophisticated example, though, and I think this is the one we want to have in our notes. We can also, this is deductive, so we can also turn it into a formal argument. The Washington Times engaged in censorship by refusing to publish controversial authors. Censorship is a violation of the First Amendment. Therefore, the Washington Times violated the First Amendment. I hope I didn't say Washington Post. I might have, though. Oh, shoot. Okay. So, let's just get this on here. And you know what? Let's do it. Let's number these premises. It's a good habit to get into. And we can just do the little c. If you guys get into numbering your premises and such, you might see a little triangle of dots instead of the conclusion. That's fine. It just means therefore, or conclusion. Okay. I'd also like to have this all on one page. Okay. Fantastic. Let's talk about what's going on here. So, what we're looking at is censorship, right? The Washington Times engaged in censorship by refusing to publish controversial authors. Then we have a definition of censorship. Censorship is a violation of the First Amendment. Therefore, the Washington Times violated the First Amendment. What's going on here? Well, we have two different definitions of censorship. An equivocation between these two different forms of censorship has taken place that allows us to get to this erroneous conclusion, this false conclusion. If censorship is a violation of the First Amendment, the Washington Times simply cannot engage in it. It is not the government. However, if we take a different definition of censorship, right, the refusal to publish controversial authors, the Washington Times did engage in it. But we need fixed definitions throughout an argument. We can't just go changing it, right? Maybe this is censorship version 1, and this is censorship version 2, right? We can see very clearly that the Washington Times did not indeed violate the First Amendment. They did something completely different, right? Because they're the same word. I want to say they're two different words. They're frankly the same word, but they have two different meanings, right? The ambiguity of meaning has led to this erroneous conclusion. Okay. On the crazy off chance that the textbook does a better job explaining this than I do, let's briefly look at their explanation. The word censorship is used equivocally in the premises. For the second premise to be true, the word must mean that some governmental agency has prevented publication by threats of punishment, right? And they don't have them numbered, but we know that this is the second premise. But that is not the meaning of the term required to make the first premise true, right? In that case, all it means is that the Times decided not to publish something that it could have published. So again, there's just an equivocation between the uses of the word censorship. We can talk about amphiboly. It is not going to be on the exam. It just makes use of syntactic ambiguity. Yeah, let's look at this very quickly. If you want to take the motor out of the car, I'll sell it to you cheap. The sentence's structure does not make it clear enough whether it refers to the motor or the car. Again, I told you guys sometimes your pronouns just really confuse me. I don't know what you're referring to in emails. If you list two nouns, right, like motor and car, your pronoun needs to clearly identify which of those two you're talking about, right? This is just semantic ambiguity. So if someone used a sentence like this to try to mislead us about what was for sale cheap, he or she would be guilty of amphiboly. Again, this is so close to equivocation. the only thing you'll be tested on is equivocation. Okay, next. So we're going to be treating the fallacies of composition and division as though they're the same. They're not actually the same, but our exam will only feature one or the other, so you do need to learn both, but they're just too close to call. And they work essentially the same way. The fallacy known as composition occurs when a feature of the parts is something erroneously attributed to the whole. Pretty straightforward, right? Division just works in the opposite. So we can put this in our notes if we want, and then we'll come back and add a definition for division. So let's look at this. This building is built from rectangular bricks, therefore it must be rectangular. We can see that that's silly, but let's look at this slightly more tricky example. The public thinks highly of individual members of Congress, therefore the public thinks highly of Congress as a whole, right? It's the same thing as the brick building, right? And we can number these if we really want to, just to get in the habit. Okay, capitalize that. All right. So we can talk about this a little bit. It is entirely possible that I respect every one of our congressmen and women, every single one of them. I could, maybe I didn't vote for them, or they represent a political party I don't particularly support, but I still think, man, this person has given their lives to civil service, or their life to civil service, and that's something I respect. I think very highly of them. But maybe Congress is too divided, and they can't pass anything. They can't pass a budget, right? It's a mess. And I could think that the whole of Congress is just a hot mess, even though I think very highly of every single individual member of Congress, right? We cannot reliably conclude, based on the first premise, that I think highly of Congress as a whole. It's not always going to be this obvious, right? We've got these helper words here, like individual and whole, but definitely do not make this mistake. It always has this feature of thinking that the parts of something is true of the whole. So that's the thing to keep an eye out for here. So, as I mentioned before, the fallacy known as division is just the same as composition, but going in the other direction. So if you want to put this in your notes, you absolutely can. Let's get this in here. All right, division is the same as composition, but going in the other direction. What does that mean? Maybe we can clarify that a bit. Maybe this is awful. Okay, so let's change this around. When a feature of the whole of something is erroneously attributed, maybe we can say as a feature of the parts. Make that a little more grammatical there. So what does this look like? Let's get an example down really quickly. During the recent recovery, my financial portfolio gained considerably in value. Therefore, Microsoft stock, which is in my portfolio, gained considerably in value. We should at this point be able to see pretty quickly what's going on here. That's not true, right? Maybe something else in your portfolio gained considerably in value. It didn't have to be specifically Microsoft stock, which was part of your portfolio, right? Maybe you had a bunch of gold or something also in your portfolio, right? So we have erroneously attributed something that was true of the parts to the whole. Oh, I'm sorry, I said that backwards. This is why I don't ask you guys to distinguish between. So again, to say that correctly, what's happened here is a feature of the whole of something has erroneously been attributed to the parts, right? My whole portfolio gained considerably in value, therefore a part of it must have gained considerably in value. Nah, not gonna work. I'm not sure what more to say about this one. These are pretty straightforward. Let's move on. Another language fallacy we're looking at is confusing explanations with excuses. Let's get this in our notes. Okay, and scroll down some because I like having room to type. So back in chapters 1 and 2, we made a careful distinction between arguments and explanations. We reason fallaciously when we take one to be the other. Right? This is a lot to put in your notes, so do it if you want to. You guys are grown-ups. I prefer the example given here. Let's see if we can copy this into our notes with any kind of reliability. Probably not, is my guess. Okay, so let's get our speaker. Says this, and then who is heckler is the other person. That should have, no, it didn't. Let's just say naysayer. That seems a bit more polite. Okay. Let's quotes around this. Somebody says, the young man who killed all those people at Sandy Hook Elementary School was suffering from half a dozen mental disorders. And then we have some naysayer, some other person, come along and say, oh, so now you're going to tell us he had an excuse for the horrible things he did? Which I like this kind of rhetorical question as well, right? So no, this is an explanation, right? It is not an excuse. It does not excuse the horrible things he did. It doesn't mean those horrible things he did ceased to happen or anything like that. It is simply an explanation. So, as the textbook points out, the speaker may simply be trying to explain why things happened as they did, which is not the same as excusing, never mind justifying, those actions. I like to take a moment with this fallacy because it does affect our lives, right? This happens quite a bit, especially in very partisan politics. So after September 11th, 2001, suicide attacks on the World Trade Center, a speaker at their university, which is Chico State University, attempted to explain possible causes of the attacks. Some assumed he was excusing or justifying the attacks. And Rush Limbaugh, the radio pundit, invited him, in fact, to move to Afghanistan. This all because an academic, a speaker, was attempting to explain and understand possible causes for the attacks. Don't do this, guys. Never do this. And I think that's all I want to say about that one. The final group or collection of fallacies we're going to talk about is miscalculating probabilities. You guys might have guessed, I love these fallacies. They're very fun to teach. We're only going to really keep one in our notes. It's going to be the name for all of these. So let's talk about them a bit, and then we'll add that to our notes. So there's a problem that occurs when we incorrectly combine the probability of independent events. Those of you who like mathematics will know exactly what I'm talking about when I say independent events. They're the two or more events that are causally unrelated to each other. So sometimes people make a mistake when they combine the probability of unrelated events. So for example, Bill's chances of becoming a professional football player are about 1 in 1,000, and Hal's chances of becoming a professional hockey player are about 1 in 5,000. So the chance of both of them becoming professionals in their respective sports is about 1 in 6,000. See what's happened there? The conclusion is incorrect. The two events, Bill's becoming a professional football player and Hal becoming a professional hockey player, are independent events, right? Bill's chances don't influence Hal's chances, unless they're like the same person or something, right? One independent event cannot affect the outcome of another. Whether one happens does not change the probability of the other. I like this one a lot, but I don't like their example, right? Sometimes you'll hear people say that you're due for a storm or some weather. I briefly lived in Oklahoma. Lived in is an exaggeration. I had an extended visit in Oklahoma where there are tornadoes. Like legit, every house has like a storm shelter. And occasionally people would say, oh, we haven't had one in a while, so we're due for one. To say something like that, unless you're basing it on, meteorological events, is to incorrectly combine the probability of independent events. The fact that you haven't had a tornado the day before or the 10 days prior does not influence whether or not you're more likely to have a tornado on the 11th day. A potentially more easy example of this to understand is this fallacious reasoning right here. Since there are 6 sides on a die, the chances of rolling a 1, a snake eye, are 1 in 6. Therefore, the chances of rolling 2 of them in a row are 2 in 12. Incorrect, right? No, those events are independent. So we multiply 1/6 times 1/6 and we get 1/36. The chances of 2 consecutive snake eyes are 1 in 36, or a little less than 3%. The example you might use in your math class is flipping a coin, right? If you just keep getting heads after heads after heads, every time you flip that coin, it's a 50-50 chance. Every coin flip is an independent event. Okay, and now we are on to gambler's fallacy. This is the fallacy that we are going to be putting in our notes as representative of all of these fallacies, these miscalculations of probability. So this is the easiest one to identify, I think, and it's also the most pervasive mistake in reasoning. So it's a common and seductive mistake that happens when we don't realize that independent events really are independent. I'm not going to put common and seductive in our notes. Okay. All right, what are we talking about here? And, if my explanation of the coin flips or their example of the die rolling sounds very similar to the gambler's fallacy, quite right you are. That's why I've grouped them all together. So here we go. The last 3 coin flips have all been heads, so the next flip is more likely to come up tails. Let's get this example in our notes. Oh, I don't know what happened there. No, that's very fancy looking. Why is it italicized? Okay, there we go. So, as I just explained, this is fallacious reasoning. The independent events are, in fact, independent, right? And this is a mistake that happens when we don't realize that independent events really are independent. I find the language in this silly, and again, this is why. This is all just one fallacy as far as I'm concerned. So let's talk about this a little bit and the mathematics behind it, because math is awesome. So it's true that 4 heads in a row is fairly unlikely, right? 1/2, 1/2, 1/2, 1/2 equals 1/16 or 6.25%. But once the first 3 heads have come up, the odds of the 4th flip coming up heads are still 1 in 2. That's 50%. Right? Remember, when dealing with independent events, past history has no effect. So the reason I like to focus in on the gambler's fallacy is also because we're in Las Vegas, right? I've heard people say that, their luck is bound to turn around or that they're on a streak, right? Both as reasons to continue gambling. This is really problematic. This is a failure to recognize that past history has no effect on every new deal of the cards, every new roll of the dice, and every new flip of the coin. You reset every time. What has happened in the past has no effect because these are independent events. Please, if you do gamble, keep that in mind. I think anyone who gambles professionally or for a living will tell you that this is a very problematic mistake. It's a fundamental misunderstanding of probabilities. Okay, very briefly before we end, we also want to talk about overlooking prior probabilities. So the prior probability of something is the probability is its probability, everything else being equal. So what the last phrase means should be clear in a moment. That the everything else being equal is what they're referring to here. Let's get that underlined. The prior probability of a coin flip coming up heads is 1 in 2, or 0.5, or 50%, right? The prior probability given a newborn baby's being male is also, of a given newborn? Oh, they mean any given newborn. So, okay, sorry. That was really grammatically strange. Since about 50% of newborns are male. If 20% of the students at your college are business majors, then the prior probability of any given student at your college being a business major is, 0.2 or 2 in 10. The fallacy of overlooking prior probabilities occurs when someone fails to take these underlying probabilities into account. So let's look at an example. So Bill is the best football player in our high school, and Hal is the best hockey player in our high school. So it appears that Bill's chances of becoming a professional football player and Hal's chances of becoming a professional football player are equally good. What is overlooked here is that the prior probability of someone's becoming a professional football player is greater than the prior probability of someone's becoming a professional hockey player. This makes reference to the earlier statement about the 1 in 1,000 and 1 in 5,000. Now you can see what we meant earlier by everything else being equal. Bill has a 1 in 1,000 chance to play pro ball, let's say presuming he has the same chance as any other player at his level. If Bill were a high school All-American, that would improve his chances, but then everything else would not be equal. He would have an odds advantage over other players. Similarly, if the dice we are rolling are loaded, the prior probabilities of a given number coming up will change, since not all the numbers will have an equal chance of coming up. This is very large and complicated. I would highly recommend you try to think of some examples on your own, but be aware, thinking probabilistically, going with your gut is not adequate, right? We tend to think that independent events are not actually independent. That's what our gut tells us, and we tend to miss other probabilities, prior probabilities that might be at play when we're trying to predict the statistical likelihood of any given outcome. So, very briefly, there are several more. I don't know if I really want to dwell on any of these, but if you guys are liking this stuff, you can make a request and we can talk about them a bit more. I don't want to overburden you guys with them, though, so you'd have to make a special request. Okay, that is everything. We are done with fallacies now. We only have a few language fallacies, right? We've got 3, effectively. Well, we have confusing explanations with excuses, too, so 4. And then we have our 3 formal fallacies. If you've been struggling with fallacies, if you feel you don't have room in your brain for all of these formal fallacies, these 3, they are big. They're a big deal. we're going to be working with these fallacies and deductive reasoning for the remainder of the course. So if you want some extra homework or exercises to do that we can grade or talk about, please let me know. We have to be able to recognize these. The remainder of the class depends on your ability to recognize this sort of reasoning and when it works and when it doesn't. Again, we will continue to build on this, but now is a really good time to just nail down your understanding of formal structure and start to get a feel for looking at arguments that look like this, right? Maybe even with P's and Q's. Okay, thank you guys. I will see you next week. And yeah, that's it. We're done with fallacies. Woohoo! Or not. I like fallacies. So thank you, everyone. See you next week.